This is Trigonometry, video 5.1, part 2, since we got cut off there. So I think this one loading gave us a little bit of trouble, but we get to see overall all of these things that we were talking about, the A, B, C, and D. So the period right here, the time that it takes for it to repeat, so to go all the way from the top to all the way to the top again. In the cosine function, we see there it is 2 pi. In the sine function, it is also 2 pi, so to go from any one point on the graph to its exactly repeating point right there is known as the period. How long did it take for it to happen? So in both of these, we can see that if I adjust the A, which in the equation right here is the one in front being multiplied to the equation, it adjusts the amplitude, so the height of the curve there. So notice when I moved it from its regular understood 1 to a 4, the height of the curve, instead of going from positive and negative 1, now goes all the way up to positive and negative 4. I can put him back down to his regular 1 right there. Or you'll notice that I could even slide him down. I could make him a smaller curve. Oops, that's too small. It's a fraction right there. More shallow curve, you could even make him go negative, and just like we talked about, the negative flips it over. So instead of starting out as going up first, now it starts out as going down first. So if you were to actually plug in those x's, just like we did when we started things out with the sine curve, and evaluate those functions, each time you would get an answer, you would multiply it by 3, and that negative, which would make him come down first and then up. So let's put him back to regular right there. And notice the b. So the b right here is going to change this number. When I slide him up, watch what happens to the curve. It gets more frequent. So it did not affect the height. The amplitude is still 1, but you can see there are definitely more squiggles here. So let me make him an even number, there 4. So notice that the period is now 1/2 pi. So it went from 2 pi to 1/2 pi. It only took a fourth of the time for this period to repeat, for the curve to repeat himself. So when I made him go higher, the period got shorter. So it's this inverse relationship. So remember that everything inside was a little bit backwards, a little tricky. The sign was backwards from what you thought, the plus minus, and the horizontal stretching and shrinking is a little bit backwards from what you think. So a larger number inside makes it get more frequent. It makes the period get shorter, okay? Since it's more frequent, the period gets smaller. Okay, we can find the new period by taking the old period, 2 pi, and dividing it by that factor, the b, whatever's there inside of the curve. So let's set him back to normal. So use normally the understood 1. And this c right here was the plus or minus, so you'll notice that he affects the left and right. See how the waves just kind of flow across right there? So if I were to subtract 2, that actually made him shift horizontally to the right 2. So again, remember, it's a little backwards from what it seems. So let me shift him back down to our 0, which is normal. And one more, the d, this number right here on the outside, shifts him up and down. So this is the phase, or no, this is the vertical shift. This is the phase shift. So we can do all of these with the sine or the cosine. I can slide multiple things, so I could change the frequency and the amplitude and shift it left and right and up and down. So with this, you can kind of see some of the graphs that get tricky. So this can be a very helpful tool, but be careful not to overuse it. Don't get too dependent on it, because of course when you're on the actual test, you will not be able to use these sliders. So you'll need to be able to recreate these on your own. So because of that, it gets a little bit sneaky. Let me set these back to 0 here. Because there's a difference between graphing things out on paper, where you can kind of put the points you need in first, and graphing things on XYZ. So we're going to see how that works. So back to our note page, we talked about A, B, C, and D. We saw them on the sliders, and you can click that link and play with those all day long if you want to. We can find, like I said, the period taking the old period, which for sine and cosine is 2 pi, and dividing it by b for those two special ones, the tangent and cotangent. Remember that they had this special period of pi, but we're going to talk more about them in section 3. In section 1, we just kind of get used to sine and cosine and we only play with A and B. And then in section 2, we'll start playing with C and D as well. So we're going to kind of ease into it there. So just to make sure that it makes sense, why it gets more frequent, why it's backwards from what it seems, let's test those points again one more time for a cosine of 2x. Now let's first decide what 2x would be. So we're going to make another column right here. So we're going to find the x. I'm so bad at making straight lines. There we go, close enough. The 2x, and then we'll find what cosine of that 2x would be. So 0 is x, so 2 times 0 is of course still 0. But then cosine of 0, well, we found that on the last page, was equal to 1. Okay, nothing new there. Now here's where it gets a little different because pi fourths times 2, 2 times that pi fourths would reduce the fraction to pi halves. Okay, because remember 2 would be 2 wholes, 2 over 1, and that 2 and 4 would reduce to pi halves. Now cosine of pi halves was 0. It was right there on the top of the x-axis. So in our unit circle right here, at pi halves, the cosine was 0. Okay, at pi halves, if I multiplied that by 2, 2x would be pi, 1 whole pi. Cosine of pi is back over there on the left side of the circle at -1. So you're going to start to see a pattern here. If I multiply 3 pi fourths by 2, same thing as this one, it's going to reduce to 3 pi halves. Remember that that's down there at the bottom of the circle, 3 pi halves, where the cosine is 0. So you may have already caught on to the pattern here. Pi times 2 would be, of course, 2 pi, which means I've come full circle back to 1. So let's keep going through these. If I multiply this one by 2, just like the others, it reduces 5 pi halves. While he's not on your unit circle, this is why I like radians better. Watch. So here's my full circle, which of course is 1, 2 pi's. So if I wanted to count by fourths, I'd go 1 fourth, 2 fourths, 3 fourths, 4 fourths. 4 fourths is 1 whole pi. So if I needed to know 5 halves, I would be counting by halves. Here's 1 pi half, 2 pi halves, 3 pi halves, 4 pi halves, which is 2 wholes, 5 pi halves. So I come right back around. So that's why I like radians, because if you add that in degrees, it'd be something weird. You'd have to use a calculator. But when it's these fractions, you can just count them up. So 5 halves was 1, 2, 3, 4 halves. 4 halves is 2 pi, 5 halves. Okay, so 5 halves was back up there, the same as pi halves, which was 0. If I multiply this one by 2, that cancels and leaves me just 3 pi, which remember you would go 1 pi, 2 pi's, 3 pi's. So it would put you right back here at pi. And at pi, we found that the cosine was -1. So you're getting that pattern, you probably guessed it. If I multiplied this by 2, it would reduce to 7 pi halves, which would be the same as 3 pi halves, which of course had a cosine of 0. And one more, 2 pi times 2 would be 4 pi, which means you've gone all the way around the circle twice and landed back again at 1. So let's go in and graph this. So at 0, it had a cosine of 1. At pi fourths, okay, be careful, the x was pi fourths. This was us working it out. So at pi fourths, here's 1 fourth, 2 fourths, 3 fourths, 4 fourths. So here's pi fourths. He had a cosine of 0. At 2 fourths, which is pi halves, halfway between 0 and pi, he was all the way down to -1. 3 halves, pi halves, 3 pi fourths, which is right here. We're back at 0 again. Remember that you're looking at the original x's, not the 2x. I almost confused myself there. And when we got back to pi itself, we were back up here at 1. We'd made one full cycle. We'd gone from 1 down to -1, back to 1 again. So continuing on with these dots, we see that by the time I reach 2 pi, I have actually made 2 full cycles instead of the normal 1. So like I said, just do your best not to make them pointy, but other than that, if they are not the most beautiful curves, it's okay, as you see mine are not. but do your best not to make them pointy. That's the main thing because they are roundy curves. So then it asks how many actual periods did we go through? What would be the new period of cosine of 2 pi? How long did it take to make one full cycle? So instead of the normal 2 pi period, this one got doubled. So it took half as long to make a full cycle. So the new period is pi. Okay, from 1 to 1, or from 0 to 1 full pi, we went full circle. Okay, so the number of cycles was 2. He went down, up, down, up. Okay, now my cycles look kind of weird there. Number of cycles. Okay, so this is his new period, and this is the number of cycles. All right, let's try a couple more. Now, in these, even though we don't talk about the vertical and phase shift yet, none of them get changed. I want you to kind of recognize where they would be. So in this one, there's no plus or minus on the inside, which means there was no phase shift. There's no plus or minus on the outside, which means there was no vertical shift. Okay, same story for this next one. There was no plus or minus, so no vertical shift, no plus or minus on the end, no phase shift. I said that backwards, but still, none of those. Instead, we changed the amplitudes and the periods in this first section. So notice out here that I have a number out front, so that changed not the period like this one where the 2 was inside with the x here. So this one affected the amplitude. This one is going to double the amplitude. He's going to go up and down to 2 instead of 1. Now this negative is also going to flip it over, but it does not change the amplitude. You would never put -2 for the amplitude because amplitude is the absolute value. Okay, just how much was he going up and down? Now the period is that number inside, so for this problem here, there is nobody in there with the x, so he's going to stay the normal period of 2 pi. Okay, for sine, cosine, secant, cosecant, they all have a period of 2 pi. So let's see what this one would have looked like. Normally sine would start out at 0. Okay, normally he would circle, make a full circle by 2 pi. Now notice that that's a little bit off of our track, so we're going to have to kind of think through this in pieces, which is where XYZ gets a little tricky. So instead, if I think through a second point, in my normal in my normal sine, by pi halves, he would have reached the top at +1. Okay, this would be a normal pi. But this time he got doubled. The amplitude is 2 instead of 1. And instead of going up first, he went down first. Okay, sine of pi was 0. 0 times anything is still 0. So my shape would end up right there. Now going back the other way, if I had gone negative pi halves on my unit circle, going this direction, my sign would have been a -1. But since this has now been multiplied by -2, that's going to bump him up to +2. And then back down here. So normally when I'm graphing these by hand, I try to find those points, okay, just a few XY points where I can see the full cycle, okay, complete up and down to the top and the bottom. And I try to kind of go halfway between to see where those max and mins are. So we can kind of see a little bit of everything here. Now graphing this on XYZ, let me show you which buttons you're going to need to push to make it give you this shape. Okay. All right, so on number 1, it wants just regular sine. So if it wants regular sine, sine is the one in our notes that we discovered started at 0. So we kind of think through things starting out from the middle of the graph rather than the top or bottom. In cosine, we start out at the top of the graph. So instead of starting out in the middle, we start with the top or bottom. So the buttons on XYZ reflect that. So right here, if I'm doing sine, I need to select this button. This is for sine because it's going to start us in the middle. This one will be for cosine because it starts at the extreme. So using my sine button, I select that he starts here at 0, 0, and then notice as I move away, I can make whatever sine graph I need. Okay, so it wants the next point to be at the maximum, and the maximum of sine is 1, and that maximum is reached at pi halves. So notice here's full pi, so pi halves would be halfway between, up there at 1. Now every single problem changes the scale, so they do that on purpose to really test your memory, okay, to make sure you're thinking through it right, rather than just trying to visualize the box that you're used to. So the main thing to focus on right here, started at 0 for sine, I went up first for sine, and before I click, I visually kind of check what's going on right here at 2 pi, because I know at 2 pi he should be back to 0 again, making that full circle. That way if I'm just a little bit off to the left or right, I say, wait, he's not hitting my 2 pi right there where I need him to be. So if I were like right here, I would see that it's off from the 2 pi. See, I needed him to start my 0 right there, even though it looked pretty close to half. So when I click him right here, oops, see, I got just a little bit off right there before I clicked. So even though it's close, it's not quite there. Sometimes it takes it. Okay, sometimes it's close enough it'll take it, but he should have been just a teeny tiny bit more to the left. All right, so you do have to play with those just a little bit, but don't hesitate to do those similar problems. This is one of those things you really want to practice. So in this one, it wants the period, amplitude, phase shift, and vertical shift. There's no plus and minuses, so I know that there was no phase or vertical shift. The amplitude is what got changed here because it has a 4. So an amplitude is 4, and the period is my normal 2 pi. Not pi. There we go. All right, this one was a sine, so again, I'm going to use this button. Okay, sines start at 0, and instead of reaching a maximum of 1 like we're used to, this one reaches a maximum of 4. Okay, now notice how they've changed the scale on me. Here's my pi halves. The period did not change. Notice that it didn't give me a 2 pi to check myself, so instead I can check myself here at pi, make sure I hit 0 like I expected. Okay, so you kind of have to play with this a little bit, because like I said, it changes every single problem. It's really going to test your knowledge there. And then let's try number 8 right here, no, number 9 right here, where we change both things. So this one changed the amplitude and the period. Okay, so let's work one on paper first. Here we go. So this one where we change both the amplitude and the period. Change colors here. All right, the amplitude is the absolute value of that number. In this case, it's positive, so it just stays positive. The period, remember, is always going to be 2 pi, the regular 2 pi, divided by the b, the number next to x. So in this case, that is 1/4. So remember that that's dividing by a fraction, so it's really 2 pi over 1 times 4 over 1 flipped over. 2 pi times 4 would be 8 pi. This one's actually going to take 8 pi's before it comes back full circle. So in my sine, I would start here at 0. My amplitude is only a half, so the maximum I'm going to reach is 1/2. And he's not going to come back full circle until he reaches 8 pi. So I put a dot right here knowing he's going to come full circle. Since it's sine, he would have come back to the middle, at the middle of this curve. So notice my sine, it hits 0 at both ends and here in the middle. He reached his maximum halfway between the first dot and the second dot. Okay, and the maximum in this case was only a half instead of 1/2. He reached the minimum halfway between these two dots, so that would be right here. So to me, that's easier to work out on paper because I can look at all 5 of these kind of key points at once. Okay, So on XYZ, it's a little bit trickier. So let's look at that together. So here I've got that same exact thing. I'm going to use my sine curve right here, which starts at 0. But notice as I move away, so I only want an amplitude of 1/2 instead of the regular 1/2. But I have to try to move this so that it makes the full cycle at 8 pi's, which is a little sneaky. Okay, so sometimes it helps to write things out on paper, just like I did here. Make yourself a really rough sketch where you can see those 5 dots instead of having to try to think through the middle dot first thing. So once I kind of see, okay, halfway between 0 and 8 was 4, halfway between 0 and 4 was 2, now I can see that my maximum of 1/2 should be reached right here at 2 pi. I double check my other points, and sure enough, here it came full cycle at 8 pi. So it really takes some getting used to. So really get in there and practice. Make sure you're comfortable with this program. Ask me lots of questions. Okay. All right, now one more in here that kind of tries to twist your brain a little bit. Remember that I said that radians don't always have to include the pi, so they tricked us up a little bit here and made the b 4 pi. Okay, notice pi's not normally in there. Normally it's just the x. So the amplitude did not change. It's the regular amplitude of 1, okay, because it's 1 unless you change it. The period is normally 2 pi, but what they did is they put a scale of 4 pi in there. Well, 4 pi means those pi's are going to cancel and leave the number 1/2. So instead of what we're used to, cycling at 2 pi or 8 pi, this one's actually going to cycle at the number 0.5, 1/2. There were no vertical or phase shifts involved. We just have to kind of tweak our minds to make a full cycle at 1/2. Okay, so that means halfway between these two, it hits 0 again. Halfway between these two, he would hit the maximum. There was no amplitude change, so that would be at positive and negative 1. Okay, try your best to make them curves instead of points, but other than that, you can see I'm not a master at making them pretty. Now, real quick, let me show you one more because we didn't get to see a cosine. Let's see if I can get a cosine to pop in. There we go. Okay, so the cosine works about the same, but we need it to be this one right here. So we go top to bottom, which is kind of weird. So we're actually not going to start it here at 0. Cosine starts at the maximum. This one had an amplitude change, so instead of the normal maximum of 1, he starts at the maximum of 4. He comes full cycle at the normal period of 2 pi, okay, which means he'll reach the top again at 2 pi, which is slightly off of our graph here. He reached the bottom at the halfway point. So looking back at our graphs here, here was my full cycle at 2 pi, which means halfway between 0 and 2 pi, he was at the bottom, okay? And halfway between those two, he hit 0 and 0. So sine went middle, top, middle, bottom, middle. Cosine went top, middle, bottom, middle, top. Okay, so when we're graphing that on XYZ, I started at the top and then I make the next dot at the bottom. So if my normal, it's not working, hang on. Oh, okay. So if my normal period is 2 pi, then without a period change, halfway between pi and 2 pi would be right here at pi. So he should reach the bottom at pi. Okay, so cosine, you make the 2 dots at the extremes from each other. Sine, you make the 2 dots from the middle and then to the top. So it tries to help you out there since that's kind of how you think through things. It had the normal period of 2 pi. It had an amplitude of 4 instead of 1. And no phase or vertical shift. Okay, so play with it. Let me know what problems you have, because it does take some getting used to. All right, one more, the word problem, but don't worry, it's secretly easy. So this one kind of gives us a scenario that actually has a cycling curve like this, so a spring. So somebody, pulled the spring in outer space where things are not going to slow it down like gravity and stuff, and they found that it just kind of kept going up and down and up and down and up and down after they stretched that spring out. So the equation that represented the bottom of the spring at any point in time was given right here. So starting at the top, because it's a cosine, they pulled the spring down, it went twang, and kept going like that. So it asked us, knowing what we do about the trig functions now, what do these numbers really mean in terms of this context? So if it asked for the velocity, well, the velocity is the frequency. It's how fast is that spring twanging up and down. Well, that is related to the period. What happened to this period? A cosine's normal period, if I can spell, velocity, there we go, I'll do this, relates to that period. The normal period is 2 pi, but they have a b right here of 2 pi, and 2 pi divided by 2 pi is 1 whole. So that means it would actually take 1 second for it to complete a cycle and go all the way from the top, since it's cosine, all the way to the bottom, back up to the top again in 1 full second. So that would be this cycle. And then the maximum velocity, well, that is how high and low did it reach. That is the amplitude. So the maximum velocity of this function is 3.7. And that's it. So that's the word problem. It's the easiest one in the batch. So please give these some practice. Play with that little sliding scale that I gave you to kind of see how the numbers work. But like I said, just be careful not to get too dependent on it. Don't keep putting them in there and then trying to transfer over to the graph, because at some point you'll need to make them all on your own. So practice that. Let me know what I can do to help.